Hello everyone and welcome to your Chem 113 review on the net ionic equations of precipitate reactions. My name is Jason and I work for the ASU Tutoring Centers. Now let's look at the reaction we're doing here. We are reacting barium chloride with potassium sulfate, okay? Now these are both ionic equations. Typically when you react, ionic compounds, that's the word I was looking for. They're both ionic compounds. Now, typically when you react two ionic compounds together, they will react in something called a double displacement reaction. I know this goes by several different names. The name I know is double displacement reaction, but you may know it by something else. And essentially what happens is you just swap the ions. So instead of barium chloride, you would sort of swap the chloride and sulfate. So when you take barium chloride and react it with potassium sulfate, you'll basically swap the chlorine and the sulfate and the potassium and the chlorine. Now we'd have to make sure we balance this, right? All I did was I just switched Cl2 and SO4, but this is certainly not balanced, not necessarily at least. So let's see what's happening here. If we look at the charges of everything, on the left-hand side, everything's balanced, because I mean, it had to be balanced here. On the right-hand side, barium's +2 and sulfate's is -2. So barium sulfate is balanced. And same thing here. Each potassium is +1, +1, and each chlorine is -1, -1. But we would never write K2Cl2, because you see, it's already balanced by just having one potassium, one chlorine. So instead we would just write KCl and put a 2 out front. Because K2Cl2 doesn't really make sense as an ionic compound. It's written like it's supposed to be a molecular compound, or rather a covalent compound is what I should call it. But it's just an ionic compound, so that wouldn't make sense. So there we go. This is our balanced chemical reaction. This double displacement reaction. Now the next thing we need to do is know the states of these things. That's written in the problem, including states, but it's also just necessary to know in order to do the net ionic equation of this reaction. So we will use our table to the right over here to determine the states of all these things. I'm not going to do that because we already did that in a previous video. I'm just going to write what all of the states are. Aqueous, this one's solid, that's 2 KCl, aqueous. So essentially, if your compound is soluble, you would write AQ, which means aqueous, or aqueous. I've heard it called both ways. And essentially this means that like it can dissolve. It is ionic in nature, where it'll dissociate into two things, into two ions, okay? Whereas if it's non-soluble, you would write it as a solid, because it's not dissolving in the solution, so it is settling as like a solid, usually on the bottom of the reaction vessel that you're working with. Okay, so you're going to see aqueous written a lot in the future. It's very common in chemistry because ions is where a lot of the magic happens, particularly in like electrochemistry or in acid-base chemistry. Okay, so now the idea is the ones that are aqueous, well, because they're soluble, they're going to dissolve into ions. So why not just write them out as ions, right? So instead of having BaCl2 aqueous, we would really write it out as what it truly is. It is barium ion, aqueous, and 2 chloride ions, aqueous. And same thing here, this potassium sulfate, we have 2 potassium ions, aqueous, and a sulfate ion. And this is producing barium sulfate solid, so we can't rewrite the barium sulfate as its 2 ions because it's a solid. It's not aqueous, it doesn't dissolve in the solution. But we can rewrite the 2 potassiums and the 2 chloride ions. And now what you do is you look at your reactants and you look at your products and you ask, okay, what's actually participating in this reaction? Because if I look here, I have 2 chloride ions at the beginning, and I have 2 chloride ions at the end. So the chloride ions really aren't participating in my reaction at all. So what I can do is I can actually just kind of ignore them, get rid of them, because they're not doing anything. They're just hanging out there. What we call these spectator ions. That's because they're just spectating. They're not actually participating in the reaction. Similarly, we have these 2 potassium ions as products and 2 potassium ions as reactants. We can sort of ignore those as well, because again, they're not participating in the reaction. And then if we just look at what we've simplified down to, on the left-hand side, we have barium ion. Oops. Keep trying to write the Q first. Aqueous. Plus the sulfate ion, aqueous, yields barium sulfate. I didn't really need those parentheses there, but you know, solid. Yeah, so that's the idea. That's the idea, is the only thing actually participating in the reaction is the stuff that produces a precipitate, or precipitate meaning like the solid that accumulates in the beaker. So this is what our net ionic equation is. You ignore the stuff, you ignore the spectator ions. That's how you form your net ionic equation. Wonderful. All right. Well, thank you very much for watching. As I mentioned, I work for the ASU Tutoring Centers. If you want more information about the tutoring services available on all 4 major ASU campuses and online, check out tutoring.asu.edu/content/tutor-search. When you go here, you'll be able to find a tutor on your specific campus or online that'll be able to help you with your class. Thank you again for watching, and I hope you have a wonderful day.